Good morning, and today I will be sharing the charge model example with subtraction. Okay, so on my screen, I'm using the T-chart method to help organize our thinking. And notice at the top of my T-chart, I've devised my key. Okay, in this case, I'm going to use the red counter for negative and the yellow counters for positive. Keep in mind that students need to reference the key prior to beginning any activity as it relates to integers, because it's very imperative that they examine the key first, as it will denote the respective positive and negative quantities. In some instances, you might see keys where these have equal a 1 for the positive side and a negative 1 for the negative representation. So also be sure to share those types of examples with students. In previous teaching experiences, I've used the macaroni, right? So the elbow macaroni pointing to the right was positive, or pointing up was positive, and then the macaroni elbow pointing to the left or down, right, was representative of negative quantities. And then when you put these together, right, because the elbow macaroni looks like this, it forms a 0. Okay, so another idea or activity that I've used in the past is that you paste the elbow macaroni on the index card and you arrange them in a manner, or you give them in two baggies, and students must arrange them to develop what they believe is a possible expression. It could be an addition expression or subtraction expression, in which they use a four-square model then to solve whatever expression that they create based upon the number of elbow macaronis and the arrangement, right? Because again, with the elbow macaroni, the direction to which they face helps determine positive versus negative. So that was just an added benefit to using the elbow macaroni. Okay. So with this example, I wanted to step through the process that occurs when we do a charge model to demonstrate subtraction. And I know that many of you have already shared processes with students in order to achieve success with this. And some of you have reverted to using the algorithm that you learned when you were in school regarding changing subtraction expressions to addition expressions. However, the caveat with that is that you're actually using a principle or rule associated with multiplication, and then it becomes blurred to students when they are asked questions regarding how to model subtraction using these counters and or algebra tiles. Okay, so I just wanted to demonstrate really quickly how easy it is for students to understand this based upon what they've learned all the way back in second grade. So you begin the conversation about the actions that take place with subtraction. And more than likely, students will say to take something away, to get rid of something, to remove something. And those are the things that we want them to express, because that is the action that we're going to take place using the counters. Now, you have to keep in mind, how can you denote this on paper? And I'm going to demonstrate that using my whiteboard, as you see on the screen. Okay, so with modeling, remember, it's helping kids to get the big idea. So don't use very large numbers. Try to stay in the range of a -10 to +10, or even smaller than that. The examples I'm going to use for this portion of my presentation are going to be very small, because I don't want to keep clicking buttons and drawing arrows. So let's keep that in mind, because once you do enough problems in a systematic order, and I'll explain the order that I'm choosing to do my presentation in, students will begin to understand some very large, big umbrella ideas that they they are expected to know at this level. And one way to excite students about this is tell them that they're learning pre-algebra. These ideas and concepts surrounding integers help prepare students for Algebra 1, which is a high school level course. Okay, so the first example, we're going to jump right in. We're going to do 3 minus 5. 3 minus 5. So 3 minus 5. All right. So this means that I have 3 and want to take away positive 5. Okay, so if you have 3, do you have enough? So talk about having enough and using the first integer as the integer that we're going to place in our T-chart, and or I like to call it a system. You can call it a board, that's the term, or mat as termed with using algebra tiles. So on my T-chart, I will place 3 positive tiles because that's what I have. So notice I'm actually using the draw feature here. I'm going to the circle, and then don't forget to change the color. And for positive, I need yellow. Notice I'm using the right side of my T-chart to denote the positive quantity, and I wanted the filled in circle. So let's undo and make sure you choose the filled in circle. So filled in circle, I already have it set on yellow. I need 3. 1, 2, and 3. I have 3 positive. Now, you say, do you have enough to take away 5? And we do not, because we only have 3. So that would mean that we need some kind of way to add 2 more positives. And then here begins our discussion of properties of real numbers. What number can we add to 3 that will not change the value of 3? And hopefully your students will say 0, okay? So then if students still aren't understanding, begin to write expressions that showcase this concept of the additive identity, which is 0 in this case. So then I would come over here in my little note section and put some examples. You know, what is 3 plus 0? And everybody will say 3. All right, what is 1 plus 0? Everybody will say 1, right? And then, you know, get kind of crazy with it. What's 15 plus 0? 15. What is 100 plus 0? Again, trying to get them to recognize that 0 can be added to any quantity and the value be retained or kept, right? Sometimes students will think of multiplication for some reason and then will say that the sum is 0. So remind them that they are adding versus multiplying, all right? So now that we have this understanding that adding 0 to any quantity will reserve that quantity's value, you talk about how do we represent that on our mat or in our system? And that's the discussion of the 0 pair. Okay, a 0 pair, and here's how you can tie in future content, is when the ratio of negative to positive is the same. So it's a 1-to-1 ratio. Okay, here's how you can tie it back when we get to ratios coming up in the end of October. All right, so here I would just say 1 negative to 1 positive. And if you need to draw it out or write it out, that's fine, because students need to know that. If they have forgotten, hopefully they hadn't. So I'm just going to come down here and say 0 pair. 0 pair. 1 positive. And 1 negative. Okay. So if I know I have 3, I want to add a 0 to this, I need 1 negative and 1 positive. So that's what I'm going to do. So I'm going back to my draw. I'm going to my circle. I'm changing my color to red, and I'm going to add it right here. So one positive and one negative, okay? Be sure that you do both. Okay, so it's always two parts. All right, so then you say, all right, do I have enough in my system now to take 5 away? And you can count them 1, 2, 3, 4. No, so let's add another 0. So you can come back over here to your list that you've created and say, what if I added another 0? Does that change the value? So if I did 3 plus 0, is the answer still 3? And of course, the answer is yes. So again, anytime you add, or the number of zeros you add in this case, right? Adding, talking about the expression, not the number, okay? Because trailing zeros and whole numbers is something different. See how it's important that we look at the verbiage we use with students, okay? Because, you know, sometimes they say add a 0, the 0 has no meaning, et cetera, et cetera. Here it has a meaning and a purpose, and it's gonna help us solve this problem, okay? So now I'm gonna add another 0. So again, go back to my draw, change my color to red, close circle this time. 1 to 1, yellow, here we go. All right, so now let's count my system. All right, so I have 1, 2, 3, 4, 5 positives in my system. Can I take away the positive 5 now? And the answer is yes, because I can see it in the system. So to denote a takeaway when you're writing, because this is to simulate how you want students, or the expectation of how you want students to show their work when they write, right? This is like if they have to turn in something, if they're doing their scratch work or proof page, again, with the tools, you would physically take them up, right? But we know in some instances, students will not have those tools unless they have an IEP or 504 with those accommodations. We want them to emulate that same processes or series of processes when they show their work. So again, model those expectations with students. So if we were in the physical realm, we would actually pick them up and take them off of our system and or mat. But in this case, I'm demonstrating how you would have students record. This is what I would have students to do, and hopefully it will work for me on this board. So I'm just gonna go to my black to simulate my black pencil. And I would have students group the amount that we want to remove. Right, so I want to remove 5. 1, 2, 3, 4, 5. Make sure you count it. It's a positive 5. And then I'm going to draw an arrow like this, and I'm going to put R, M, V for remove. Okay, or you might have them write it out. It's all to your expectation. So once these are removed, I don't want to X through them, because I want them to be able to still see the amount that was taken away, okay? Once these are removed, what is left? And what is left on our board, and I'm gonna go to a different color just to help recognize this, is this quantity here. And I usually use a highlighter, and then I write the word difference, D-I-F-F, difference abbreviation, okay? So students know the essential vocabulary associated with the resultant of a subtraction expression, okay? So when we perform 3 minus 5, we now know that the difference is a -2. So now let's talk about, what if students chose to add additional zeros? Will that change our answer or difference of -2? What would the board look like? What would be some next steps a student would have to do? So let's just dive right in. If I were to add, make me change my color back, another 0 pair. So here's another 0 pair, one negative, excuse me, red, and one positive, okay? Right, that is 0, okay? Then you say, how many positives do we have on our board? The answer is 1, 2, 3, 4, 5, 6, right? But we only need to take away how many? 5. So if we were to go ahead and remove the 5, right? Notice then we still would have 1 red, 1 negative, 1 yellow, 1 positive. And what happens when a red and yellow are still together? It forms 0, okay? So even though we have 2 different colors on our board, that signifies that a 0 still exists, right? And it can be removed because 0 reserves the value of the given quantity, okay? So if you have students that want to put 50 million zeros, remember when you find your resultant after completing a step or operation, the resultant should be of 1 color and 1 color alone. So in this case, our difference is a -2, even though I still have this red and yellow present, because I know when a single red and yellow meet, it forms 0, right? And 0 is that additive identity, So let's try a new problem. I'm just gonna clear my board, clear all drawers. So the next problem I would like to do, make a new T chart, okay? And I actually got this T chart from my godchildren, who I sent them a problem and asked them to model it for me. And this is how they showed me their result. And they also showed me on the number line. I hadn't used the T chart when I was a classroom teacher, but I like this organization. And I definitely would recommend keeping that order consistent with the number line, with the positive being on the right and the negative being on the left. To me, it adds to children's understanding. So again, I'm gonna, need to switch to my closed circle. Here's my positive quantity, change my color, my negative quantity, okay? So the next problem I want to do is a -3, -3, and please look at the problem sets I'm choosing to do. And there's a reason why I have chosen these sets and the order to which I've chosen them. So this time I'm doing a -3, and we're going to remove a +5. So this time, when I go to my draw, closed circle, I'm starting with 3 negatives. And notice I tried to keep them close to this vertical line because it helps demonstrate the 0 pairs. It works wonders when you do addition, right? Because they see the 0 pairs right there being met at the vertical line. It's easier to circle them in that manner. So here again, we have 3 negatives. We need to take away 5 positives. I do not have that to take away, so I need to add some zeros because 0 is the additive identity. So in my conversations in solving this, I would bring that to students' attention. Do I have enough, class? No. What number can I add that does not change the value of my system? A 0. Why is that important? Because 0 is the additive identity. What will it look like when I put it on my mat? 1 positive and 1 negative together. What colors will they represent? In this case, 1 red and 1 yellow. So let's do that. 1 red, 1 yellow. Change my color. All right, so then you say, can I take away +5 now? No, so what do I need to do? Add a 0. How do I do it? 1 red, 1 yellow. Well, 0 is called the what? Additive identity. Again, every time. Here's that repetition, right? Again, you're modeling expectations, you're having them use essential academic vocabulary, and modeling and recording information appropriately to simulate how you want them to show their work. All right, so I do it again. 1 positive, 1 negative. So there's my yellow. And notice, please make sure you do it positive, negative, or negative, positive, so they can see that you're doing both. Don't add all one and then add all the other. Do one positive, one negative, one, because it reinforces the idea of the zero pair. All right. Do I have enough now? No, I got to keep going. All right. One positive. Change it to yellow. One negative. Do I have enough? No. Let's do it one more time. Negative. Positive. No. Let's do it one more time. Make it look a little more circular. So that's 4. Let's do one more. All right. Here we go. And my positive to match up with that one. All right. So now, do we have a positive 5 that we can take away? Let's count it. 1, 2, 3, 4, 5. Can I take away a positive 5, class? Yes. Change my drawing tool. Turn it to black. Pencil it out. Circle it. Arrow. R. M. Oops, come on. Pencil. V. Remove. All right, when I do that, what remains? Again, I put my equal sign, right, and count it. 1, 2, 3, 4, 5, 6, 7, 8. What kind of 8? It's a negative 8. How do we know? They're all red. How do we write it? Negative 8. Okay, so negative sign and the 8. So the difference is what, class? Negative 8. Where is it? Right here. So again, you may say, why is he having them group this? Because they need to know that the resultant, in this case called the difference, is a group. Okay, and that group is a group of -1 8 times. Okay, so this is the difference. So -8, and I put DIFF, DIFF. Again, here we go. We're recalling the academic vocabulary that students should have recalled from earlier grades. All right, so the difference is -8. All right, so let me talk about the next sequence of questions I would ask. I would then do 3 minus a -5. So 3 take away a -5. And I want to discuss this because I've witnessed several teachers revert back to the ideas that they used when they were possibly in Algebra 1 or pre-algebra when they were in school. And many of the teachers from those years had students to convert the subtraction statement to an addition statement. However, in doing so, that means you have already learned the idea behind the multiplication rule of 2 negatives make a positive, all right? So a negative times a negative, right? The product of 2 negatives is or results in a positive. That is not the rule that is used when subtracting. And students try to apply this rule when subtracting, and teachers misspeak when they have those expressions to work with. So please be cognizant when you are asked to model, because students will see questions involving modeling. That's the bullet point A, okay? It also includes questions that does not require modeling, but again, they will see at least one modeling question as it relates to integers. And we want to ensure that they accurately understand how to model using the various tools, okay? And the charge model is one of them. So let's demonstrate this one. Again, first let me record the problem. The problem is 3 minus. And again, when you record problems and you have a integer that is negative following a subtraction, please use parentheses. Okay. So this is the question we are about to evaluate. All right, 3 minus a -5. So 3, and we're going to do what? Take away a -5. So let's set it up. Here we go. T-chart, go to my black. Oops, wrong pen. I want this one. I want black, not gray. There we go. All right, draw, close circle, red for my negative, and I will want yellow for my positive. Again, I would put a plus sign and a minus sign just to reiterate in the event that a child didn't hear what you said, they did not copy it down, right? This is a positive and this is negative, okay? All right, here we go. So you always start with the first number from your expression. So that is the 3. So let's put that down. It is positive. So I need to make sure I'm in my closed circle. Here we go. 1, 2, 3. Can I take away a -5? No. Do you have a -5? No. How do I know I don't have a -5? I don't see 5 negative chips, Mr. Thomas. That's how I know it's not a -5. Again, these are the types of questions you should be soliciting of students to ensure that they are, 1, familiar with the tools, 2, following along with you, and can determine if it is or is not, right? The counterexample is always a way to check for students' understanding. Okay, remember that, comparison, contrast. All right, moving on. So how can we then subtract the -5 if we don't have it? We're gonna add 0. Why can I add 0? Because 0 is the additive identity. What will it look like? 1 red and 1 yellow chip together. So let's do that. I am on my closed circle. I don't know why I like to start with red first. So here we go. Red, and then switch to yellow. That's 1, 0. Red to yellow. Do I have -5? No. Let's keep going. All right. Red, yellow. Do I have -5 yet? No. Let's keep going. Red, yellow. Do I have -5 yet? No. We need to keep going. How will I know? I will know when I have 5 red chips. Do I have 5 red chips yet? No. So that means I need to do what? Add another 0. Why can I add a 0? Because 0 is the additive identity. What will it look like? 1 red, 1. See how it's redundant to you, because you're probably going to say it 3 times if you teach 3 blocks, but the kids are going to, it's going to get ingrained in the brain. Remember, 7 to 10 repetitions helps elongate into long-term memory. All right, here we go. It becomes what we call routine. 1, 2, 3, 4, and I need 1 more. Red and yellow together, 0 pair. Wonderful job. Y'all are on it. All right, so now can we take away -5? How do I know? I see the 5 negative chips. How are we gonna denote that? We're gonna group them together, draw an arrow, and put remove. So 1, 2, 3, 4, 5. Let me go to this. Let me change to black. Let me make my group, or halo. I like some people, or lasso, think of Wonder Woman. All right, add my arrow, and I'm gonna put remove, or abbreviated. Right, this is not how you spell remove. This is an abbreviation for notation. All right, so what remains? 1, 2, 3, 4, 5, 6, 7, 8 is a positive 8 because I see, right? What do you see? What do you notice, right? Use those question or response stems. I see 8 yellow chips, and yellow denotes a positive 1. So this difference, 3 take away a -5, results in a positive 8. So I would come and replace the question mark with the 8. I would come, use a different color, right? Because we don't want to get students. Remember, I would use, a highlight. and write the word difference. DIF. Again, this is not how you spell difference. This is for notation purposes, okay? And this is a negative, oh, excuse me, a positive 8. Again, why? Because they are all yellow chips. So again, the resultant must be of the same color. Anytime that you see two different colors, that means something is occurring, a reaction, and that reaction, in this case, one red to one yellow is a 0. Okay, so the next problem that I would do is the -3 minus a -5. Would talk to the students, what do you wonder? What do you think will occur, right? You have them model it together. So the next set of questions after I would do that example, it would prove to students that subtraction is not commutative. So talk about what is commutative. You should have already discussed how to model addition using your counters, right? So here, this is how you reintroduce those properties to students so that they know that subtraction does not commute. So I would do 5 minus 3, get an answer, compare it to 3 minus 5, right? I would do 5, take away a -3. Again, compare that to -3 minus 5. What do you notice? Okay, did we get the same result or difference? So what does that tell you about subtraction? It's not commutative. You can't switch them, okay? Then I would do -5 minus 3, followed by -5 minus a -3. Again, having those conversations, you make point to the properties that we can use because it's not math magic, right? There's a system of properties of real numbers and properties of equality that help us do things that we do with these integers. So that is all I would like to share as it relates to subtraction using two color counters, which is called the charge model. Okay, the T chart is the organizational form that I chose to use to demonstrate this. I would also reiterate properties of real numbers that assist us, such as the additive identity of 0. Keep in mind, sometimes students think of multiplication and simply when you say it, they automatically say the answer is going to be 0. So do some examples: 3 plus 0, 5 plus 0, 100 plus 0, 1,000 plus 0, 1,000,000 plus 0. And then they will understand. I also like to hold up my hand and talk about when you look in the mirror, your identity, you see yourself back, right? So 0 will return what you start with, right? So it's an additive identity. How do you represent that on your mat? Reverts back to the processes of modeling. So they would need to know that one red and one yellow. Talk about what do you see, because what you see is what you can take away or move. All right. So if you don't have that quantity to take away, you're going to have to add some zeros, and you can add as many zeros as you need to, because one red and one yellow in this instance will always generate a 0, which then can help you remove the desired quantity. I hope that this helped your students with modeling subtraction using the charge model. Stephen Thomas, the math guy, signing off. Thank you. Have a good day.